Hello and welcome to this video lecture presentation on angles. And trick is we're going to be graphing, showing our angles. There we go. We're going to be showing our angles from the positive x-axis. Ignore that line. And then we're going to create a second line. This point right here where two of our lines are going to meet, one from the positive x-axis, and then whatever line that we create, this is going to be from the vertex. This is going to be called the terminal side. And then an angle is going to be created. Now you can see here, as you take this line and make your way towards the left, it's going to go in a counterclockwise direction, and it's going to give us a positive angle. Now, if we start from the initial side, which is a positive, these are the same thing, and you go to the left in a clockwise direction, you're going to end up getting a minus angle. When we graph, if we were to go completely around, that's one full rotation, that's going to be 360 degrees. Okay, let's move on now and talk about coterminal angles. All right, so coterminal angles will have the same initial side, meaning that that this side right here is the same, and the terminal side is also going to match. However, it's the direction in which you're calling out the angle. So if you go in a counterclockwise direction in this example, you're going plus 60 degrees. However, you could go clockwise instead of counterclockwise. You go clockwise. And in order to reach this point right here, just remember one full rotation is 360 degrees. Well, if this wedge right here is 60, then you have to go 300 degrees in the opposite direction to get to the same point. So 60 degrees and minus 300 degrees are coterminal angles of one another. Okay, very quick. Degrees can be broken down into minutes and seconds instead of having a decimal degree. Okay, or you could convert degrees to radians. We're going to look at both of them here. All right, so if I want to convert 90 degrees into radians, the conversion factor to do that is always pi over 180. So you can see here that if you put 90 over 1, 90 goes into 180 twice while 90 cancels to 1. 1 times pi is pi, 1 times 2 is 2. So 90 degrees is the same as saying pi over 2 radians. Remember, the conversion factor to go from degrees to radians is pi over 180. To go from radians to degrees, what you have to do is you have to multiply by the reciprocal, 180 over pi. So if I want to go from 3 pi over 2 to degrees, you multiply by 180 over pi. Your pi's will cross cancel. 2 goes into 180 90 times, while 2 cancels to 1. 3 times 90 is 270. Now let's look at converting from degrees and minutes to decimal degrees. Well, this is all based off of a clock, okay, where if you have minutes, that's what this is. If you have minutes, if I want to convert it to a decimal degree, there's 60 minutes in 1 hour. So in one full rotation, you have 60 minutes. Well, I only went 53 minutes. So I want to find that ratio of how far I went. So you just simply divide 53 by 60 to get 0.88. So 17 degrees, 53 minutes is the same as saying 17.88 degrees. To convert 154.36 degrees into minutes, now you just do the opposite. Instead of dividing, you're going to multiply. Because basically we're saying that we went, to find out the minutes, we only went 36% of the way. So you take 36% or 0.36 of 60, and you'll get 21.6, or you can round it up to 22. So 154.36 degrees is the same as saying 154 degrees, 22 minutes. Very important note is that the initial side we said is the positive x-axis. That is called the standard position. Okay, so if we look at this example here, it says draw the following angles in standard position, 60 degrees. So we're between 0 and 90 in our graph. So that put us somewhere here. Here's 60 degrees. This was drawn from standard position, the positive x-axis. So that one's done 130 degrees. That puts us somewhere in quadrant 2. So going from here to here is 130 degrees. If I wanted the coterminal angle, go this way. Basically, I would have to go minus 230 degrees. Because one full rotation, the 130 plus the 230, will give you 360 degrees. The minus sign comes in simply from the fact that we're going in a clockwise direction. All right, next is 225 degrees, so that's going to put us somewhere in quadrant 3. So here's 225 degrees. Now, if I wanted to go from here to here, that would basically be 135 degrees. So you just subtract 360 from 225 to get that angle amount. Okay, and then minus 120, that'll be in quadrant 3. We're going from 0 to minus 90, and then here's minus 90 to 180. We could show it like that as well. This is minus 90, minus 180, minus 270, and then you could say minus 360. It all depends on the direction you want to go. So 120 minus 120 will bring me somewhere here. That's minus 120. If I wanted to go in the other direction, my coterminal angle would be 240 degrees. So that's how that works. I hope that makes sense. Okay, and that looks like it's the same slide. Okay. All right, and that will include our initial discussion on angles, coterminal angles, degrees to radians, and drawing angles in the standard position. Thank you very much for listening and watching, and have a good one. Bye-bye.